everyone. Today we are kicking off Chapter 9, and Chapter 9 is all about polynomials. The first lesson, or really the first couple of lessons, focus on several different polynomial operations. And so all of these sections that we're going to be working through, and this will be divided into multiple videos, are really just meant to flex your algebra muscles a little bit. Do you know how to combine things with variables? Do you know how to multiply things together? Do you know how to simplify fractions? Do you know when you're allowed to add terms together and when you're not? That kind of thing. Okay, so the first thing we're going to talk about is the degree of a polynomial. That's some terminology that you may or may not remember from last year. But the degree is the largest power of a term in a given polynomial. Okay, and we'll kind of talk through what that means. But that idea of degree is really important when it comes to graphing polynomials, because the degree of the polynomial sort of affects the shape of the graph. So we're not going to be getting into graphing quite in this section, but being able to identify the degree at this point is important. So if you've just got a polynomial, and by the way, I don't know if we've talked really about what a polynomial is, but a polynomial is just an expression with variables. It could have a single variable or it could have multiple variables like this one. But it's got individual terms that are all separated by addition and subtraction. And we're going to learn some different terminology for these polynomials as we go through. So this first one is in a single variable. You'll notice everything is just x's. And so the degree would be the highest power or the highest exponent that you see, which in this case would be the 5. So we would say this thing has a degree of 5. Okay. Now, when we're working with something like this next one where there's multiple variables in a single term, we look at the total degree of each term. So if this is a power of 1 on the a there, and that's a power of 4, then this term really has a total power of 5. We combine those exponents together. This term has a total power of 4. This term here, the a and the b each have a power of 1, so this would have a power of 2. And then because this 20 doesn't have any variables at all, we would really say this has like a power of 0. And so then for the degree, again, we're looking at the highest combination, the highest total down here, which again in this case happens to be 5. So both of these are 5th degree polynomials. Okay, so this next section focuses on addition and subtraction, which is really all about combining like terms. Remember, you can only add or subtract things together if the variables are exactly the same, meaning powers and everything. And then when you do combine, you don't change those powers at all. You're really just changing how many of them you have. So it would only affect the coefficient. So if this is addition in the middle here, I don't have to worry about distributing or anything like that. I don't have anything that needs to go into these parentheses. I really don't even need the parentheses in this case when it's addition. I'm going to talk a little bit about this one down here, that's subtraction, when we get there. But I'm kind of disregarding these parentheses, and I'm just looking for my like terms. Okay, I'm just looking for my things that are exactly the same. So let's see, I have a 4x cubed y and a negative, remember this is really like a minus 1x cubed y. So 4x cubed y minus 1x cubed y leaves me with 3x cubed y. And in a problem like this one, I tend to cross these things off to let myself know that I've already used that one up. I don't see any others that have a power that have an x squared and a y to the 5th. And again, it has to be exactly the same for both variables, so like this one wouldn't count. So I'm just going to go ahead and put this one in here. 7x squared y to the 5th. Get rid of that guy. This is a 10xy squared, and then I have a 3xy squared. So altogether that leaves me with 13xy squared. And I use those ones, and then my last one here is this minus 4x squared y squared. So that's it for addition. Addition is really just combining like terms. Subtraction, the only thing you have to look out for is technically when I say that I'm subtracting this parenthesis, I'm subtracting every single thing inside those parentheses. And what that's going to end up doing is switching the sign on every one of these. So I'm going to think of this, I want to think of this as an addition, excuse me. So I'm changing this to a plus, but then because of that negative sign that was there originally, I'm changing the signs on all of these. So this will now be a plus, this will now be a plus. Okay, and again, I'm doing that because when I subtract a 5r squared, it's going to be like a negative 5r squared. When I subtract 11r cubed, it's really like a negative 11r cubed. When I subtract a negative 6r to the fourth, that's really going to be like a plus 6r to the fourth. So I distributed that negative sign in there, and then once I did that, I can think of this now like addition, which allows me to disregard those parentheses. So in this one, I'm also going to emphasize writing my answer in what's called standard form. Okay, I'm just going to make a note off to the side here that standard form is when the exponents are in descending order, meaning they go from largest to smallest. We typically try to write our polynomials in standard form whenever possible. It gets a little messy when you're working with multiple variables, and that's why I didn't care so much about it up here. But for something like this, where it's only in terms of r, I would go for standard form. So my biggest degree here, my biggest exponent is a power of 4. So let's start with that. I have 4r to the fourth plus 6r to the fourth. So altogether that makes 10r to the fourth. Notice I didn't change the r to the fourth. I only changed how many of them I have. Now let's look for an r cubed. The only r cubed I have is this one, and that's a negative 11r cubed. Okay, these problems are tedious, but you've just got to be really, really methodical about them. You've got to be really careful not to mix up your negatives, to make sure you do your adding and subtracting correctly. Lots of little mistakes happen with these. Most people get them conceptually, but lots of little stuff happening. Okay, I see a 3r squared minus 5r squared. So 3 minus 5 gives me a negative 2r squared. Let's cross those guys out. My next one would be just a regular r, and so I have a negative r plus 5r. Okay, so negative 1 plus 5 leaves me with 4. And then I have, let's get rid of those. We've used all those now. And so then I think I have just a plus 6 left over here at the end. And that would be my final answer. That's as far as it can go. I can't combine anything else because those powers are not the same. Okay, let's start doing some multiplying and some exponents and that kind of thing. So first of all, we want to make sure we're following order of operations. So I see 3 different things going on in this problem. I see powers, right? We've got a power here, 2. I see multiplication in between these parentheses, and I see a subtraction here in the middle. We want to make sure we're working through this carefully and in the correct order. And for order, we want to make sure that we're following order of operations. Okay, order of operations here. So we need to do our power of 3 first. In this case, this is a single term of a polynomial. I know it's a single term because I don't see any addition or subtraction. Addition and subtraction create separate terms. This is all one term. If it's all one term, I'm allowed to just apply this power of 3 to everything inside the parentheses, almost like the distributive property. Okay, that's going to be different when I have multiple terms, and we'll talk about that on some examples in the back. What I want to make sure that I remember is this 4 is just a regular plain old 4, and it does need to be raised to the 3rd power. So I'm not multiplying here, I'm raising to a power. So 4 to the 3rd power is 64. Okay, that came from doing 4 to the 3rd. The reason I made a big deal about not multiplying here is when I go to work with these exponents, when I'm doing like x to the 4th to the 3rd power, the rule here, because these are exponents is I'm just going to multiply these together. But sometimes we get so wrapped up in the idea that we're going to be multiplying here that we accidentally multiply with the 4 as well. You need to make sure that that 4 gets raised to the power of 3 and not multiplied by 3. So this would become x to the 12th. The y would become y to the 6th. And the z would become z to the 3rd. Okay, I'm going to go ahead and just write that next parenthesis down because I need to multiply it, but I'll do that in the next step. Minus, now let's go ahead and raise to the 3rd power here. So once again, I can just take this power of 3 and apply it to the x squared and to the y. Make sure both pieces get it. So that's going to become an x to the 6th and a y to the 3rd. And then I have this other parenthesis here. Okay, my next step, according to order of operations, would be to do the multiplication. So I'm going to combine these two things, and I'm going to combine these two things. Okay, when I'm multiplying, remember my numbers, so the 64 and the 2 are just regular numbers. And so if I'm doing multiplication, I'm treating those like regular numbers, and I'm going to multiply. 64 times 2 is 128. But when I multiply powers, so for example, x to the 12th times x, for example, and that's like x to the 1st power, right? When you're working with the powers, the rule for multiplying powers together is that you add the exponents. We covered this in the beginning of the last chapter. So if you're rusty on those rules for exponents, you can look back at the beginning of chapter 6. So this would become x to the 13th. Y would become y to the 7th. And then z to the 3rd, there's nothing else to combine it with, so it just becomes z to the 3rd. Minus, now let's go do the same thing over here. As far as my numbers go, this is really like this has a 1 in front of it. So 1 times 2 is 2. X to the 6th times x to the 4th gives me x to the 10th. Y to the 3rd times y to the 5th leaves me with y to the 8th. And then once again, I've got a z squared that doesn't get a partner. Okay, my last step would be subtraction, which really takes us back up here, like when we were doing subtraction. But the thing is, remember that addition and subtraction only work if you're dealing with like terms. And so if you look at the arrangement of variables here, they do not match, which means I can't do anything with this subtraction. I can't actually subtract these two things. And so this thing here is just as far as I can go. That's as simplified as it gets. Now, if I happen to give you a problem where the variables worked out to be exactly the same in both terms here, you could go ahead and do that subtraction. And I do think that shows up on your homework once or twice. So just be careful for that. But I can't go any farther in this one because my variables don't match. Okay, that's going to do it for this video. This lesson will continue in a second video. So please make sure that you jump on and watch that next video. But thought it would be helpful to break this into pieces because it's a lot to watch all at once. So have a great day, and I will see you in a few minutes in part 2.